Here we come to DSE Physics Practice Paper Structure Question 3. In here, we have a ball X slide along a smooth track, and then when it slides to here, it hits ball Y, and then therefore ball Y is ejected with a horizontal speed, a horizontal projectile, and therefore this ball Y follows a projectile path, a projectile motion, and then hits the ground at point S. So we can basically separate this motion into three parts. Firstly, is the ball X slide along the smooth track, and so it gains speed. And second part of the motion is that ball X will collide with ball Y and make ball Y being projected at a horizontal speed. And third part of the motion is that ball Y would follow the projectile motion until it hits the ground at point S. Okay, so here the question gives us some information, but basically we need to know how are we going to solve each section of the motion first. At the first section, because this is a smooth track, so there is no loss in energy, no loss in mechanical energy. So basically we would use the principle of conservation of energy or mechanical energy to consider this motion. And secondly, we would have a collision in which we can apply the principle of conservation of momentum to solve for the motion after collision. Finally, we have a projectile motion. So we can use the method we learned in chapter 8 to solve this. So firstly, let's focus at the collision part first. The collision part is like this. The ball X originally moving to the right at an unknown speed. We would like to find the value of this unknown speed towards ball Y. Okay, so we have a ball X and ball Y. After a while, they collide with each other. So we have a collision, and then after the collision, ball X remains at rest. Ball Y move to the right hand side with a speed of Vy. So basically this is what happens in the blue section, the collision. Okay, so now we would use the conservation of momentum, and therefore we can write down mx ux plus my uy equals mx vx plus my vy. There are two things we need to note. One is, initially, ball Y is initially at rest. So we can write down uy is 0. Secondly, we see that after the collision, ball X comes to rest. So we know that Vx is also equal to 0. So let me write that down. So now we are going to put in the numbers. We have been given the mass of metal ball X, it is 0.03, and also we have the mass of metal ball Y, which is 0.04 kg. So we can put in 0.03, ux is an unknown, Uy has been 0, mx, okay, don't forget that Vx is also 0, so no need to consider about this term. This should be Vy. Vy is equals to 3 meters per second, as stated here. So, solving this equation, this would give us Ux is equals to 4 meters per second. So therefore, we know that before the collision, ball X is moving with a speed of 4 meters per second. So that means ball X has KE because it's moving. But think about why does ball X have KE? It is because the PE, when ball X is at point P, when it slides down the smooth curved track, the PE will be converted to KE. So in part B, you are asked to find the value of H. What is H? H is the height of this smooth track where ball X is initially released. So here we apply the principle of conservation of energy. Originally, we have when the ball X is at the highest point at point P, we would have PE of mgh. And later on, when the ball slides down, PE will be converted to KE, so it will becomes half mv. I should write U squared. Let's put in the numbers, and also note that mx on both sides can be cancelled out. So G is 9.81, H is what we want to find. Ux is the speed of ball X at the lowest point of the track, which is equals to 4. Okay, we have already calculated this. Solving this equation, we would have H to be 0.815 meter. So now we know the value of H. We know the speed of ball X before the collision. Then let's take a look at another part of the motion. That is, let's look at the green part of the motion. The ball Y is being collided and it is projected at a speed of Vy. We know what is the speed of Vy because the question gives us this information. Ball Y moves off the bench horizontally with a speed of 3 meters per second. So that means this speed is 3 meters per second. So as usual for projectile motion, let's assume the moment when the ball is being projected, the time is equal to 0, and when it hits the ground, the time is t. First of all, we would like to find what is the time t. How can we find the time t? In this case, we will consider the horizontal motion. Why? Because for the horizontal motion, we know the horizontal displacement. Sx is equal to 1.2 meter. Also, we know the speed of the ball, the horizontal speed of the ball, which it is projected 3 meters per second. With the speed And with the displacement, we are able to calculate the time. Okay, so this is what we are going to do. So by considering the horizontal motion, Sx equals v, I would write vy because it's the velocity, the speed of y times t. Sx is 1.2, vy is 3, t is what we want to calculate. T is equals to 0.4 second. Okay, so we had find the time t when the ball has hit the ground, 0.4 second. Starting from this point, 0.4 second, it hits the ground. So we ask ourselves another question, is that in this 0.4 second, what is the height of the ball that has been dropped under gravity? This distance would be the height of bench H. Okay? So we can consider the vertical part of the projectile motion. We use the equations of motion Don't forget that because it is a horizontally projected particle, Uy is 0. Sy is the displacement of the ball during this 0.4 second, so it is equals to the height of bench h. Under gravity, Ay is 9.81. T is 0.4 second. So the bench height would be equal to 0.7848 meter. Okay, so we had calculate this. Lastly, it is said that ball X is now released at Q. Where is Q? Q is here. So it is released at a lower height. Okay, not as high as P. Okay, we release at a lower height. So when ball X reaches point R and collide with ball Y, we know that it would move with a smaller velocity, slower speed. Not hard to imagine that when ball Y is being projected, it would also be projected with a smaller speed. What would happen if it is projected with a smaller speed? Originally, the projectile path is like this. When it is projected with a smaller velocity, the projectile will be something like this. The ball Y will hit the ground at a closer position, closer to the bench. So when this happens, would the time of flight of ball Y change? The time of flight depends on what? The time of flight depends on when ball Y needs to go from here to here. It has to drop for a height of h. As the original initial projection speed is a horizontal velocity. Okay, so it is not related to the vertical motion. So the vertical motion will not be affected by whether the horizontal speed is fast or slow. So here is the explanation. The horizontal motion and vertical motion are independent to each other. The time of flight depends on the vertical part of the projectile motion. As both the initial vertical speed, which is 0, and the vertical displacement remain unchanged, the time of flight of the ball will be unchanged. Okay, so here, be careful about the horizontal part of the motion and vertical part of the motion should be independent. And in this case, the time of flight, that is, the bow eye, when it goes from here to here, how much time did it use? It depends on the vertical distance. How long does it take to go from point A